Hi, this is Mike, and today I'm going to show you how to model a DC motor control system in Simulink. In short, Simulink is a package that comes with MATLAB that allows you to do these simulations, and it makes it really easy to set up a simulation and get information back to MATLAB and make changes to the simulation. So to get started, all you have to do is type Simulink into the command window in MATLAB, and this library browser window over here pops up. And if you want to start a new document, all you have to do is click this white page here. If at any point in time this library browser disappears, you can go to View Library Browser to bring it back up. Alright, so now we'll actually build a little simulation to demonstrate how Simulink works. And the nice thing about Simulink is that you don't have to do any coding. You just drag icons in from over here on the library browser. So the first thing we're going to do is we're going to go to sources, and we're going to bring a step in. This is one of the most common inputs. What it is just a signal that goes from 0 to some final number at a particular time in your simulation. So I'm going to have it go from 0 to 1 at time 0. So it'll just go from 0 to 1 right as soon as the simulation starts. And I'm going to come up to continuous here, and I'm going to grab the transfer function block, and we will connect these two together by clicking on the arrow here and dragging it over to the transfer function. And then we are going to need another block to show us what's actually coming out of our code. So I'm going to go to syncs, and we're going to bring in a scope. And then you can also hold the control button and click on the block that you want it to connect to. Move that over like that. So if I double click on transfer function here, I can change some of the parameters, as you saw me do before with the step function there. So the motor we're going to model is a little Lego motor, and I will just give you the transfer function so that we don't have to derive it. So it's going to be 2.921 times 10 to the minus 5, comma 0.0315, comma 0.5048, then comma 0. And if we make our block a little bit bigger here, we will eventually be able to see our transfer function. So now let's run this and see what happens. And I can double click on the scope to see the results. And right now it doesn't look like much, so you can click on this button to auto scale it. And what we see is as the time goes from 0 to 10 seconds, the output position of the motor goes from 0 to 20 kind of in a line, which is sort of what we expect, right? When you put a voltage on the motor, the output position is going to add up from 0 to 20. So now let's model a proportional control system using Simulink. And what our proportional control system is going to do is it's going to take our output position, and it's going to set our input voltage to the motor depending on the error in our signal, which will be some reference minus whatever our current output is. So I'm going to click on these two lines here and delete them. Let's move that transfer function over. So to do that, we're going to need a couple more math blocks. So we'll click over here on math operations, and we will find the addition block here. Pull it in like that. And I said I want to subtract out the the current position of the motor. So we'll double click on the add block, and we will change the list of signs to plus and minus. And as you can see, this changed to a minus sign. And we will move that up like that. Connect that to our transfer function. We will connect the transfer function to the scope. So now we need to bring the output signal here back to the minus sign on our addition block. So I can right click and hold on the output and drag this over like that, and then I'll just left click on this arrow and bring it up to the minus sign. And I will connect the step into add here. And let me just explain quickly that the purpose of this control system, again, is that we want to be able to control the output position of a motor. So we want to command it to go to a particular position. In this case, because our step input is 1, we're telling it to go to a position of 1 radian. And we want the motor control system to provide whatever input voltages to the motor it needs to get there. So if we run our simulation and we look at the scope, we can see, all right, we move from a position of 0 to a position of 1 over, a number of seconds, which is what we were expecting. So this looks pretty good. Now, the one thing that we usually want to do in control systems is we want to be able to change what's called the gain, which is how much the error, aka our reference minus our current output, kind of how that maps over to the voltage input to our motor. So I'm going to drag in one of these gain blocks here. And so before, because we didn't have any gain, we effectively had a gain of 1. But now we'll see what happens if I change this to a gain of 5 and run the simulation again. Open the scope up. So now we see we're getting somewhat different behavior here. Before we had kind of a nice rise and it flattened out around 1, whereas here we have this little extra bump at the start. And you can see that our simulation is mostly kind of this flat line here, and we don't get a whole lot of information about really what's happening at the start here. So let's exit out of there. You can change your simulation time up here, and let's make it 1 second, because that seemed like about the amount of useful time we had in that last display. And we open this up, click auto scale again. So now you can see a little bit more of what's happening in our system. And we're going to experiment with changing this gain around. So we'll maybe make this a gain of 10. See what happens. Auto scale again, and you can see now the behavior is changing even more. So here's something we may want to take a look at. Over here we're looking at our output position over time, but we may also want to know what kind of voltages are we supplying to our motor. So I can take the scope here, and if I hold control, click, and drag, it basically just copies and pastes the second scope in there. I'm going to right click on this line coming out after our gain here, which, remember, this is our voltage input to the motor. Now I'm going to run the simulation again. Double click on scope 1 and bring that in here. So this is our voltage. We start out at 10 volts and it sort of goes down and does some other things on the way out to where we've reached steady state here in our other graph. But the real question is, what if our voltage supply can't supply 10 volts? At some point we could make this gain here 30, and then our initial voltage is going to be 30 volts. So that's going to be a problem, right, if we're only supplying, say, 5 volts to our motor maximum. So this problem is what's known as saturation, where we can only put a certain maximum voltage into our motor depending on our voltage supply. So if we come over here to discontinuities and saturation, we'll drag that block into our display. Now we may have to do a little reorganization here. Move this guy over. And now I'm going to delete this line here, bring in the saturation block, and connect these all together. And again, I want to watch the voltage on scope 1. So now let's, one thing first, we have to set what voltage limits we actually want to saturate within. So let's say we're using a 5 volt supply, and we can do 5 volts to negative 5 volts. So we'll go play again. Now we will double click on our scope. So now what you can see is we're at 5 volts initially instead of 30 volts, and then we dip down, we saturate again at minus 5 volts, and then it kind of looks more or less like we had before. So this is going to be really useful for making a simulation that actually represents reality. So I'm going to show you one last thing here. If you want to get the data out of Simulink and into MATLAB so that you can make some nice plots, combine it with other data, or do some analysis on it, you can go over here to Sinks and Sim Out to Workspace. Bring that up here. Now I'm going to right click and hold again, connect that, and if we double click on it, we need to give it a variable name, so we'll give it something descriptive like sim data. And there's a couple of different save formats here. We'll just do the time series for now, and we can run our simulation again. So now we can go to MATLAB, and we have this new sim data that should have shown up in your workspace. So, and it has 2 pieces of information there. One is the data, and one is the time series. So if we do sim data dot time, there are time values for this simulation, and we can do the same thing dot data to see the data values. So if we do plot sim data dot time on the x, and then sim data dot data on the y. And we get the same plot that we had over in Simulink. So that's all there is to it. You'll have to modify your diagram to include derivative control. So here's a hint, it's over in continuous. But other than that, hopefully this was a useful tutorial to help you understand how to use Simulink.